Welcome to Spring LIB.
This is the answer to Chapter 12, problem number 56 from the Smith Organic Chemistry textbook. And in this problem, we're given several molecular formulas and other pieces of information, and we are asked to determine the structures of several molecules. And so to start, we're told that molecule A has a molecular formula of C10H18O. And so if we calculate the hydrogen deficiency index for A, we get the number 2. And the other piece of information regarding A that we're given is that treatment with sulfuric acid gives us B and C. And then for B and C, we're told that they have the same molecular formula. It's C10H16. And calculating the hydrogen deficiency index for C10H16, we get the number 3. And so this tells us that molecule A has 2 rings, 2 double bonds, or a ring and a double bond. And then B and C each have 3 rings, 3 double bonds, or some combination thereof that adds up to 3. So the next piece of information that we're given is that B and C, when they're treated with hydrogen gas and palladium on carbon, give us this fused ring system called Decalan. And so we know now that B and C both have this carbon skeleton with a double bond somewhere in the molecule. And then we're also told for B that treatment with ozone followed by dimethyl sulfide gives us this molecule, which the problem has labeled D. And so right there, the first one that we can actually definitively solve for is B. So as we've done before, we just reconnect these 2 carbonyl carbons, sort of undo the ozonalysis, and we get this structure for B that I've drawn over here on the right. And so that's B. And then we know that C is essentially, a very similar molecule, probably just differing in the position of its double bond. And so we're told for C that ozonalysis of C gives us E, and then E has a molecular formula of C10H16O2, and the hydrogen deficiency index for E is 3. And so that's pretty important because when you stop and think about this, so when you ozonalize B, you get this molecule. And so when you ozonalize C, you're getting, so how best to put this? Okay, so E has a hydrogen deficiency index of 3. So we know that it has 3 double bonds, or a ring and 2 double bonds, or some combination of double bonds and rings that adds up to 3. And so when we look at this, we can put this together with what we know about B and C. When they're hydrogenated, they give us this Decalan system. And we can imagine that if we were to break this central bond in the Decalan system, the bond that fuses the 2 rings, we would still have one big ring, and we would have 2 carbonyls. And so that actually does end up being what E is. And so since we know that that is E, we can then go and reconnect the carbonyls, and that gives us C. So if we were to sort of just shift this ring around, one position clockwise, the carbonyls would be here, and we could connect them, and we would get C. And so now that we know where the double bond is in C and in B, we can look at the carbon that they have in common, which is this top carbon of the fuse of the ring bridge, and this top carbon we know has an alcohol on it because when it's treated with strong acid, it eliminates, and we get the double bond in either of these two positions. And so that is how we determine A. So A is this Declan skeleton again, but with an alcohol on it. And so that is the answer to chapter 12, number 56.